So in CC2, you learned or saw for the first time the 5D process. Basically, what the 5D process is just a fancy way that CPM likes to use and a structured way actually, to use what I call guess and check. Okay, this method is actually pretty good if the algebraic understanding isn't quite solidified yet. So basically, you'll notice here it says the 5D process is organized way to write your equations and solve problems. So 5Ds, we got describe and draw, define, do, decide, and declare. So describe and draw, we're going to try to figure out what we're doing, okay, by drawing a picture. We're going to define what we know, so define our variables. We're going to do some work after we've stated we have a specific trial value that we want to use. We're going to decide if that works, and then we're going to declare our statement, whether it's too high, too low, and move back to another trial, or declare that our statement's correct. So we'll work on the following problem together just to make sure we understand what the 5D process is. So we have an example problem here. It says that the base of a rectangle is 13 centimeters longer than the height. If the perimeter is 58 centimeters, find the base and the height of the rectangle. Okay, so first thing, we're going to describe and draw. So you'll notice here that CPM has so nicely for you drawn a rectangle. Bam. Okay, and it's labeled the base and the height. Okay, and it gives us some information. We're going to define that information now. So the information it gives us is we have height here. We're going to height here. And we also have our base. What information do they give us about the height and the base? Well, we don't know the height, but we know that the base is our height, which I'm going to call h, plus 13. Okay, so I'm going to write that here. Okay, so we have our height and our base, and we're going to start with our first trial. So let's try, we're going to say that our first trial is 10. Our height is 10. Okay, our height is 10. Okay, so we have our height is 10. We have our base, which is 10 plus 13, which we know equals 23. Okay, now we're going to do it. What does the do column mean? Well, we're trying to find the perimeter because that is ultimately what we need to help us find out if our trial is correct. So we're going to do the perimeter. If you don't remember what the perimeter is, it's just adding up all of the different sides here. So we have a height. Okay, our height is 10. But we have two heights. We have this side and this side here. So we have our height times 2 plus our base times 2 because a base is this length and this length. So our base value we've established here is 23. So we have 23 times 2. Okay, so we add this up. We say 2 times 23 plus 2 times 10. Well, that equals 66. Okay, but we know that our perimeter is 58. So we can put a little 58 here with a question mark. Does 66 equal 58? So we decide, no, it does not. So we've done our first trial, and we've realized that our value, 66, is too high. So when we move back to our second trial, I'm going to put a line here just so we can separate our first trial from our second trial. Are we going to have a value that's greater than or less than 10, given what we realized we had the perimeter for here? Probably less than, because our value again was 66, which is higher than 58. Okay, so let's make a guess that's lower. So let's try 8. Okay, so let's do 8. So we're going to try 8 this time. So we have a height of 8. Our base is h plus 13. So what's 8 plus 13? That equals 21. Now again, we're doing our perimeter. So we have 2 times our height, which is 8, plus 2 times our base, which is 21. And notice here, we have 16 plus 42. Okay, and that equals 58. Yay. Because that is exactly what our perimeter actually is. So we know that this absolutely works. So now for our answer, we would know that our height is 8 and our base is 21, and that would be our answer. Okay? I'm going to erase this though because I want to show you how we would do it with just a generic variable x. Okay, so let's just erase what we have here. Let's erase, 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 erase. Let's see how we would do this problem if we just had x. Okay, so let's represent our height. Remember, our height was here. Our base was here, which was 13 plus the height. And our doing was the perimeter, which was 2 times the height plus 2 times the base. Okay? So, we're just going to say it's x. So we know our height is x, therefore our base is 13 plus x. Our perimeter is going to be 2 times the height, which is 2 times x, plus 2 times the base, which is 2 times 13 plus x. Now we have a multi-step expression that we can solve if we set it equal to what our value is supposed to be. So we know our value of the perimeter is supposed to be 58. So now we can solve for x to see exactly what that would be. So 2 times x, 2x. Here we use the distributive property. 2 times 13 is 26 plus 2 times x, which is 2x, and that equals 58. 2x plus 2x we know is 4x. We keep our 26 equals 58. We subtract our 26. We ultimately get, I'm going to move right over here so I have a little bit more room. We get 4x equals 32. We divide by 4. We get x equals 8, which is the exact same answer we got at the beginning. Okay? So we're going to do one more problem just to see if it makes sense. Go ahead and read the problem as I read it aloud. And feel free to do the first step, draw as I'm reading. The base is 21 centimeters, and the height is 8 centimeters. If you do not write an equation, you can solve the problem by making more trials to find your answer. Okay, so let's draw this. So it said here that the base is 21 centimeters. Okay, so you have the base is 21 centimeters, and the height is 8 centimeters. So here we can easily find the perimeter if we want. We can set up our equation by doing 8 times 2 plus 2 times 21, and we ultimately get here 42 plus 16. We get 58. Okay, but all it's telling you here is you can continue making more trials until you find the answer. So you can continue changing these values until you find the answer. That takes a little longer, but it's another strategy. Okay? So be sure that you like this video if the 5D process makes sense. And remember, every time you're doing math, you are increasing your math swag. Anyway, I'll see you next time.